everyone, in this video we will be writing the rules for translation. Let's define translation first. Translation is a term used in geometry to describe a function that moves an object a certain distance. The object is not altered in any other way. It basically makes the object slide on the coordinate plane. First thing that we need to remember here is that the shape of the object is not changed. So these two objects are congruent to each other. So they are exactly the same. And then when we say slide, it's either it moves to the left or to the right. It either slides up or down. Now let's have the rules here. First, if the object slides to the right, that would be labeled as positive. Left is negative, up is positive, down is negative. Let's take this first example right here. So this is the image. This is the pre-image, and this is the image. So when we say pre-image, that's before it slides somewhere, and then that's the pre-image. The image is after. Okay, so if it's not labeled as pre-image or image, we can actually determine it just by looking at the labels or the vertices. So in this label here, if it doesn't have a prime label, prime means it's that little tick on the upper right hand corner of the letter. Those that have ticks on them are actually the image, and those that don't have ticks on them are the vertices of the pre-image. So this triangle that we have here is actually our pre-image, and this is our image here, since again there are ticks on the vertices. Now let's determine the rules that would work for this. So as we can see on this problem here, our x, or left or right, this from A to the A prime, we actually moved one place to the right and 3 places down. So then we can go ahead and write the rule as x plus 1. So I put a plus 1 here because we moved 1 place to the right, and then we are moving 1, 2, 3 places down. So the other rule here would be y minus 3. So this is the rule for this translation. We can actually check to see by using this rule that we have here. Let's start with vertex A here. So if the coordinate for A that we have here is that would be 1, 2, 3, 4, and 3. So that's 4, 3. So that is the pre-image. Now, if we use the rules that we got here, so this would come out. So we use the rule that would be our x is plus 1. So that would be 4 plus 1. And then our y is minus 3. So 3 minus 3. So then we can go ahead and say that this is our A prime now. So then our A prime then is, that's gonna be 4 plus 1 is 5, and then 3 minus 3 is 0. So let's check if A prime is really on 5, 0. So this is 1, 2, 3, 4, 5. So that is 5, 0. Let's test for B. So let's see, what we're trying to do now is we're trying to determine if this equation or this rule that we have here works for all of these vertices. We have tested that it works on vertex A. Now let's have vertex B now. So let's have L. So there's no B, but let's change this to L. So our L here is at that's gonna be 0, 2. So that's 0, 2. So then if we use the rule that we have here, that is 0 plus 1, and then 2 minus 3. So that's going to be 2 minus 3. So then our L prime would be 0 plus 1 is 1. 2 minus 3 is negative 1. So let's see if L prime is 1, negative 1. Good. So this one right here is on 1 and then negative 1. So again, this one was 5, 0. Originally, it was at 4, 3. And then our L, originally, it was at 0, 2. And then after the translation, 1 to the right and 3 down, it went to 1 and negative 1. Now let's have the coordinate for P. So P is sitting at sitting at 3, -1. So that's 3, -1. After translation, by using the rules that we have here, that would be 3 plus 1. And then we have y is -1 minus 3. So -1 minus 3. So let's see what is p prime. So our p prime would be 3 plus 1 is 4. And then our the y here is -4. So let's see if it's sitting at 4, -4. Originally, our p was again at 3, -1. And then the p prime here is, that's going to be 1, 2, 3, 4, 1, 2, 3, 4. So it's sitting at 4, -4. So then our rule here works for each of the vertices of this triangle. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. This is our pre-image, and this is the image. Again, to determine the image and the pre-image, the image has this prime tick on the upper right-hand corner, while the pre-image doesn't have it. So this is the pre-image, and this is the image. The rule that would work for this, for the x, remember x is left or right, so we are moving 1, 2, 3, 4, 5. So we're moving 5, so that would be x plus 5. It's a plus because we're moving to the right. And then we're moving up, so up 1, 2, so that would be y plus 2. This is the rule for this given translation. Did you get the same answer as this? Good. Perfect. Now let's do it backwards. This time around, we're supposed to use this rule that we have here to draw the image. So this is the pre-image because it doesn't have the tick mark on the upper right-hand corner. So what are we going to do is we use this rule. So first is, it says that we are supposed to move, since it's a -5, that means we are moving to the left. And since this is a +2, we're moving in up. So through 5 left, 2 up. 1, 2, 3, 4, 5. 1, 2 up. So this is our Q prime. So that is, since we are drawing the image, we put that tick mark on the upper right-hand corner of the letter. Now, the same thing that we do for letter U. Again, 5 to the left and 2 up. So 1, 2, 3, 4, 5. 1, 2. So this is our U prime. So I'm going to label this as U prime. The L, again, 5 left, 2 up. So 1, 2, 3, 4, 5. 1, 2. So this is our L prime. So then we can go ahead and draw the triangle. This is our image. The original one again is called the pre-image. This one right here is our image. So pretty much like what's going on here is that this triangle slides 5 places to the left. So all of the vertices, they all go together 5 places to the left. And they went up all together, these 2 places up. And we got this image right here. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!